So, as you've said, there are two possibilities for processes to intercommunicate, either through a shared memory or through a message passing system. A shared memory is a, a space in the memory that is actually allocated to one of the communicating processes, and it allows other process to enter that space and read or write or both in that space. This communication is actually under the control of the processes itself, not the operating system. And the major issue for you is to provide a mechanism that will allow user processes to synchronize their actions, the reading and writing, when they access this memory space. One example of the mechanisms that you can use, you might recall from databases, that is locks, the read lock and the write lock. There might be other mechanisms that you can think of. Synchronization will be actually discussed in greater details later in chapter 5. The other model for inter-process communication is message passing system. A message passing system is actually more flexible than having a shared memory. They would be two processes communicating with each other through what we call a mailbox. For this, new primitives, new system calls has to be created. These are a send system call and a receive system call. So they send messages and receive messages. That also means these messages has to have a structure that both processes agrees upon. Messages can be of variable length or of fixed length. They can have flexible structure or have rigid and well-defined structure. It depends on how they agree on this. And when we say how processes agree on communicating, we're actually saying that these processes have created their own communication protocol. In message passing system, for a process B to communicate with a process Q, they need to have a communication link established. Then they have to have communication primitives that allow them to send and receive calls. Sorry, to send and receive messages. At this point, we should be asking ourselves questions we need to answer in order to design our inter-process communication system, our message passing system. How is this link established? Is the link associated with only two processes or more than two processes can share a link? How many links can actually exist at the same time between two processes? What is the capacity of the link? One message, two messages, 10 messages? What is the size of the message? Is it fixed? Is it variable? Is this communication unidirectional? That means it goes from in one direction only from A to B, or bidirectional from A to B and from B to A. And if it's unidirectional or bidirectional, who controls this? To answer these questions, we have to think and have to search, and we have to understand why and how this communication needs to happen. Usually, implementation of the link can be either physical or logical. If I'm saying physical, that means they share a memory or they share a hardware, a shared memory, hardware bus to, to actually transmit the data, and maybe network communication if these processes are not existing on the same computer. The logical part to define a link is about, is it a direct link or an indirect link? That means, is it a link that actually links directly between process A and process B, or there will be a mediator in between? Is this link synchronous or asynchronous? That means, do these processes have the need to time the communication? So the sending process will say, I'll start sending, and the receiving process will know that this is the beginning of the message. And then when it finishes, it will say that I stop, the message is finished. So the receiving process will know this is the end of the message. This is synchronization. Or asynchronous. So the sending process will just send the message, and the receiving process will receive it whenever. They don't have to synchronize this. Imagine a phone call and a text message. For a phone call, this is asynchronous communication. You both should be there, and you both have to actually have an open line between you for A to talk to B. Where sending a text message does not require this. You just send it, and the other party will read it whenever they read it. Is it automatic or explicit buffering? The buffering, does it happen automatically or explicitly? So let us look into each and every one of these. Direct communication, that means the communicating parties are clearly named. Process A is communicating with process B. Process A is sending a message to process B. Process B is receiving a message from process A. For this to happen, that means this link is direct, and they only one link can exist between two processes, just like the phone call, between two processes at a certain time. And there can be more than two processes sharing the same link. And the link is actually automatically created because process A is sending a message to process B. When that's happened, this link is created automatically. The link can be unidirectional or can be bidirectional. It depends on how the system is going to implement it and what is the actual need for this communication. Maybe only one process needs to send, and the other process does have nothing to send. So it will be unidirectional. And if they have to have both of them have to send and receive messages to each other, it will be bidirectional. If we are talking about indirect communication, this means the process is not actually sending directly to another process. There is a mediator, something in between, where process A will send to the mediator and process B will receive from the mediator. The mediator is called a mailbox. For that to happen, mailboxes has to have IDs. For direct communication, we were talking about process ID. here our process name, but here we name the mailbox, not the process. The address of the mailbox is the most important. So each mailbox has to have a unique ID. Processes can communicate only if they share a mailbox. So the communication link there will be communication link if the two processes share a common mailbox. Because this mailbox is an intermediary object, more than two processes can share the same mailbox. And each pair of processes might have multiple mailboxes in common between them. The link here also can be unidirectional or bidirectional. It depends on the type of communication and why do we need it. Instead of having send and receive primitives, here we have to have system calls to create a mailbox, to delete a mailbox, to send to a mailbox, and to receive from the mailbox. Send and receive primitives here are different than they are in direct communication. Here you send a message to a mailbox instead of sending a message to a process. And you receive a message from a mailbox instead of receiving a message from the process.